understand ideal gas equation. At constant T and N, V is directly proportional to 1 by P. This is given by Boyle's law. At constant P and N, V is directly proportional to T. This is given by Charles' law. At constant P and T, V is directly proportional to N. This is given by Avogadro's law. Now, combining all above equations, we have V is directly proportional to Nt by P. This implies V equals to R Nt by P, where R is proportionality constant. On rearranging the above equation, we obtain PV equals to nRT. This implies R equals to PV by Nt. R is called gas constant. It is same for all gases. Therefore, it is also called universal gas constant. At standard temperature and pressure, STP, the value of R can be calculated. R equals to 10 raised to the power 5 pascals into 22.71 into 10 raised to the power minus 3 meter cube divided by 1 mole divided by 273.15 Kelvin. Taking P equals to 10 raised to the power 5 pascals, V equals to 22.71 into 10 raised to the power minus 3 meter cube, N equals to 1 mole and T equals to 273.15 Kelvin. On simplification, we get R equals to 8.314 pascals meter cube Kelvin inverse mole inverse, which is equal to 8.314 into 10 raised to the power minus 2 bar liter Kelvin inverse mole inverse, which can also be written as 8.314 joules per Kelvin per mole. Note that as ideal gas equation is a relation between four variables and it can describe the state of any gas, then it is also called equation of state. No more. Let us consider for a fixed amount of gas N, the initial pressure, volume and temperature are P1, V1 and T1, and final pressure, volume and temperature are P2, V2 and T2 respectively. Then from ideal gas equation, P1V1 by T1 equals to nR. Let's call this equation A. And P2V2 by T2 equals to nR. Let's call this equation B. From equation A and B, we have P1V1 by T1 equals to P2V2 by T2. This equation is called combined gas law. The three laws, Boyle's law, Charles' law, and Avogadro's law, are combined to form a single equation which is called as an ideal gas equation. Let us solve a problem on ideal gas equation. At 25 degrees Celsius and 760 mm of Hg pressure, a gas occupies 600 ml volume. What will be its pressure at a height where temperature is 10 degrees Celsius and volume of the gas is 640 milliliter? Let's see the solution. P1 equals to 760 mm Hg, V1 equals to 600 ml, T1 equals to 25 plus 273, which is equal to 298 Kelvin. V2 equals to 640 ml and T2 equals to 10 plus 273, which is equal to 283 Kelvin. According to combined gas law, P2 equals to P1 V1 T2 divided by T1 V2. P2 equals to 760 mm Hg into 600 ml into 283 Kelvin divided by 640 ml into 298 Kelvin, which gives 676.6 mm Hg. Let us understand density and molar mass of a gaseous substance. The ideal gas equation is written as PV equals to nRT. This implies N by V equals to P by RT. Replacing N by M by capital M, we get M by capital M V equals to P by RT. This implies 1 by capital M into M by V equals to P by RT, which gives D by capital M equals to P by RT, where D equals to M by capital M, it's the density. Therefore, capital M equals to dRT by P. Let us understand Dalton's law of partial pressures. Dalton's law of partial pressures states that total pressure of a gas mixture is the sum of the partial pressures of the component gases. Here, you can observe a mixture of oxygen molecules and nitrogen molecules. In a mixture of gases, the pressure exerted by the individual gas is called partial pressure. Let us see the explanation of Dalton's law. Mathematically, P total equals to P1 plus P2 plus P3 and so on, where P total is the total pressure exerted by the system and P1, P2, P3, etc. are partial pressures of individual gases in the gas mixture. This table shows aqueous tension of water as a function of temperature. Partial pressure in terms of mole fraction. Let us suppose at the temperature T, three gases enclosed in the volume V exert partial pressures P1, P2 and P3 respectively, then P1 equals to N1 RT by V for first gas, P2 equals to N2 RT by V for second gas, and P3 equals to N3 RT by V for third gas, where N1, N2 and N3 are the number of moles of these gases. Now, total pressure P total equals to P1 plus P2 plus P3. This implies P total equals to N1 plus N2 plus N3 into RT by V. On dividing P1 by P total, we get P1 by P total equals to N1 by N1 plus N2 plus N3 into RTV by RTV. So we cancel out RTV and RTV from numerator and denominator. Therefore, P1 by P total equals to N1 by N1 plus N2 plus N3. This implies P1 by P total equals to N1 by N, where N equals to N1 plus N2 plus N3. This implies P1 by P total equals to N1 by N, which is equal to X1. X1 is called mole fraction of first gas. Thus, P1 equals to P total into X1. Similarly, for other two gases, we can write P2 equals to P total into X2 and P3 equals to P total into X3. Therefore, Pi equals to P total into Xi, where Pi and Xi are partial pressure and mole fraction of ith gas respectively. Let us take another question. A neon dioxygen mixture contains 70.6 gram dioxygen and 167.5 gram neon. If pressure of the mixture of gases in the cylinder is 25 bar, what is the partial pressure of dioxygen and neon in the mixture? Let's see the solution. Number of moles of dioxygen is equal to 2.21 mole. Number of moles of neon is equal to 8.375 mole. Mole fraction of dioxygen equals to 2.21 divided by 2.21 plus 8.375, which gives 0.21. Therefore, mole fraction of neon is equal to 1 minus 0.21, which is equal to 0.79. Partial pressure equals to mole fraction into total pressure of a gas. Therefore, partial pressure of oxygen is equal to 0.21 into 25 bar, which is equal to 5.25 bar. And partial pressure of neon is equal to 0.79 into 25 bar, which is equal to 19.75 bar.